So now, matrix method will resolve any systems of equation. Now, the first method, there are two methods I'm going to be teaching that we have learned. So we have the Crammer's rule. The Crammer's rule is the easiest, or that students find to be the easiest. Crammer's rule. That's what I'll be using first, so that you see how easy that is. And then next, we'll now use the inverse method. But you see, one thing you should notice is that these are two systems of equation because there are two unknowns there. So when you have three unknowns, there will be three systems of equation. Do we understand? Two systems of equation, two unknowns, three systems, three unknowns. All right. However, this Crammer's rule is best for two systems of equation. It doesn't mean that the inverse method cannot work too, but Crammer's rule works best, or it's faster. All right. So, like I said, the first thing you do is bring out the matrix out here. So the matrix here is 4, 7, 3, and 1. And how did I get that? Just take the coefficients of all of the unknowns here. So 4 is here, 4, 3, 3, 7, 7. If it was minus here, to be minus 7. If it was minus 1 here, minus here, to be minus 1 here. You understand? So just the coefficients is equal to, and you know I got the 1, right? It doesn't have anything here, so it's 1 invariably. So we have 20 here and minus 2. So that's another matrix for the result. Now, what you want to do is this. You want to find the determinant of this expression. So the determinant of this expression, call it delta, is 4 times 1. You multiply the main diagonal, then you subtract from the other diagonal from the minor. So this times is, I mean, we don't call it minor because there's minor matrix for it. Is that okay? For this main diagonal, 4 by 1, 4 times 1, minus 3 times 7. So, and this gives us what? Minus 21. And that gives us what? Minus 17. All right. So this is our determinant. Delta is this. Then the next thing we'll find is, we find delta x, which is the determinant of x, or more like the determinant with respect to x. So what you do is you cover all the coefficients of x, and then you replace them by the result. So the coefficient of x are 4 and 3, as we have in the equation. Then you cover them up, and you place them here. So we have 20 and minus 2. Then the other guy doesn't change, 7 and 1. You get that? So that delta x will be the normal way we take determinant, this by this, that is 20 times 1 minus 2 times 7. So this becomes 20 minus 14. So that's 20 plus 14, and that's what? 34. That's dx. Is that clear? All right. Remember, I get this one. Okay. So let's bring it here. So then let's find delta y. Is that okay? So delta y is going to be, the coefficients of y will be covered too. So we'll cover this guy, we'll replace it by this guy. Do you understand? So we have 4, 3, 20, and minus 2. All right. So here, delta y will now be 4 by minus 2. Just start getting n minus what? 20 minus 20 times 3. All right. So here, what? Minus 8 minus 60. Okay. So we have minus 68, that is. All right. So how do we now find our x? X will now be equal to delta x over delta. Do you get it? All right. So delta x is 34. So we have 34 over minus 17. Then this takes care of this. Plus divided by minus is minus. So we have minus 2. Do we understand? And delta y will be equal, y rather, will be equal to delta y over delta. What is delta y? Minus 68. So minus 68 over delta minus 17. So minus takes care of minus here, 1 here, 4. And y will be equal to what? 4. So x comma y is equal to -2 comma 4. Do we understand? All right. So let's use the inverse method now. Esther, I want you to concentrate on what I will do. In each step of the way, I'm going to simplify it. All right. It's not hard, but since it's something you've not done before, it might look. I mean, we've done inverse of matrix before. So the first thing you have to learn is find the inverse of matrix. It's very simple. Now follow what I will do. I want to first extract the matrix. Is that okay? So let me extract the matrix the same way. 4, 3, 7, 1. But now here, I want to show that what gave me this expression was just this guy times a particular one row by 2 column, right? 2 rows by 1 column matrix, right? 2 by 1 matrix is equal to 20 and -2. All right. So for the purpose of the video, let me show you what that is. Now, if I multiply this, if I multiply these two things, if I multiply them, I will get this expression. Is that okay? So let me show you how. So to multiply matrices, you take this row times this column. So how do we take this row times this column? We take the 4 times x, that gives us 4x plus 7 times y. Do you understand? So more like we are doing 4 times x, 7 times y. Do you understand? So 7 times y equals 7y. If it had been something like 2 and 3, right? So that will be 4 times 2, 8. You get that right? Plus 7 times 3, 21. So that gives us 29. Do you understand? All right. So, but this case, it's algebra. So, and the algebras are not equal. So, or are not alike. So, they won't add up. So, we have this 4x plus 7y is equal to 20. Do you see that now? All right. The same way, in like manner, we'll do this. 3 times x, 3x plus 1 times y. Do you understand? Equals -20. So that's why, that's where this thing is coming from. Do you understand? So if I call this matrix A, and I called this my result, or I still made it x, y, since it's already unknown, is equal to this my, I call this my result rather. So I call this my result. Now, to find this my x and y, what do I need to do? I will divide both sides by, does that make sense to you? All right, so we have xy equal to, now this is r over a. This thing is the same as saying 1 over a times r, isn't it? All right, so what you want to first do is find the inverse of this matrix A. Do you understand? So this is just saying that inverse times the result will give you your x and y values. All right, so let's see, make it matrix A. Let's make it matrix A. You can name it anything you want. You want to name it. So what you want to do here is take the inverse. The inverse of this, if this were a matrix A, let's say matrix A, let matrix A. Can do it that way for purpose of exams. So let matrix, you have to be explicit enough. Is that okay? And I told you in your exams, maybe it's because of their knowledge of maths, but only Joy and Tolu have been explicit, and Gladys have been explicit enough in their explanations. When they explain, when they solve questions, especially in their theory. The rest of you learn to show what you're doing. Some of you just applied formula directly. Even while that is still correct in some cases, you might not get full marks in exams where they mark by steps. Do you understand? All right. So here, you say let matrix A be 4, 7, 3, and 1. All right. So these are matrix A. So how do we now find A inverse? Since we have proven that to get this guy, we have to use the inverse to multiply this, right? So let's first get A inverse. A inverse is written like this. So A inverse will be, the formula is 1 over the determinant of A times the minor of the matrix. And how do you get that? For 2 by 2 is simple. Just interchange this one. Interchange this one. That becomes 4. That becomes 1 and 4. Do you understand? So the interchange positions. Then you put minus here and minus here. Do you understand? Idealizing that if there is a minus, there was a minus here, when you put minus, it becomes plus. Understand? Back, you got that right? Okay. Yeah. And Barak really tried in his exam. He was stopping halfway, but he did each of those things step by step, and he got determinants, he got, it was just an arrangement that is scattered and been modeled up. That was why he failed it. You follow step by step. The rest of you didn't get it at all. Yeah. I'll go help you. It's simple, eh? Do you understand? Are you following me? You say 1 over determinant of A times this guy. So, and you know how we got this guy, right? Interchange the major diagonal and then add minus to the, that's the trick for solving 2 by 2. Is that okay? This is 2 by 2. All right, so let's find the determinant of A. So what is A? This is A. So how do we find determinant again? 4 times 1 minus 7 times 3. So this gives us 4 minus 21. That gives us minus 17. Good. Minus 17. So we now have A inverse, therefore, will be equal to 1 over the determinant, which is minus 17, times 1 and minus 7, minus 3 and 4. Is this clear? All right. So from here, we'll now go here and say A inverse is equal to minus 17 times 1. That gives us 1 over minus 17. Then minus 1 over minus 17 times minus 7. That gives us plus now, right? So that will be 7 over 17. Okay, plus this time. Do you understand? Plus. No. It's not plus. We are using this to multiply this one. Do you get it? We're using this to multiply this one. So this times this. You just start getting it. This times this times this. And this times this. Minus 3 times minus 1. Minus 3 times 1. Minus 3. Minus takes care of minus 1. We have 3 over 17. Does that make sense? Yes, sir. What's the answer to this one? Good. This is simple. All right, so these are our A inverse. So we now say to find X and Y, we'll use that A inverse to multiply our 20 and minus 2 our results. So this now becomes A inverse. Am I obstructing anybody? Okay. So A inverse is this guy. So that becomes, let's say, X, Y will now be equal to A inverse, which is 1 over minus 17, 7 over 17, 3 over 17, and 4 over minus 17. We'll now multiply this other guy, minus 2, this other matrix. So what you now have is, the way we multiplied, row will multiply column. Do you understand? So to get the first guy, this row, so that will be, we can write it all together, 1 over minus 17 times 20, all plus 7 over 17 times minus 2 sharp. So then below here we'll have this guy times this guy, that is 3 over 17 times minus 2 sharp plus times 20. Okay, yes, this guy will multiply this guy, this guy will multiply this guy. Thank you. So we now have 4 over minus 17 times minus 2. Good. So, all right, so let's take it up there. So this inverse method, by the way, I didn't write it. Inverse method. All right. You got this Crammer's rule, well, right? This Crammer's rule you can solve without even touching your book. You know that, right? Mm-hmm. And there's also X present O. Oh, we will not be doing it. So we now have this. This times this will give us 20 over minus 17. Let's say you're not talking. Plus minus 14 over 17. 60 over 17 plus minus 8 over minus 17. All right, let's go step by step. So this plus minus this, since the denominator is the same denominator, right? Denominators are the same. We just pick 1, 17, and we'll have that'll be we'll take the LCM will be minus 17. Is that okay? They are not the same. This is positive and negative. Negative and positive. So we have minus 17. Minus 17, this will be 1 times 20. 20 plus 17 minus 17 minus 1. Minus 1 times minus 14. 14. Is that okay? Here, LCM is also minus 17. 17 minus 17 minus 1. Minus 1 by 60. Minus 60 plus 7 minus 17 minus 71. 1 times that minus, okay, 1 times that minus is good. Alright, so here we'll have 20 plus that, 34 over minus 17. And here we'll have minus 60 minus 8 over minus 17. So this gives us here 1, here 2. So we have what? Minus 2. And here minus 60 minus 8. That's what? Minus 68 over minus 17. Minus 60 over minus 9, 4. So we have 4. So therefore we say xy is equal to minus 2 and 4. That's how we got the first time. Alright. So that's how to solve it. I'm going to solve the second one. Which one should I solve in the other two? Which one? The third one. Was it problematic? Okay. So I'll just explain this. Is that? Let me pause that, please. Joy, pause. So this one, should we use Crammer's rule first too? Just to check. Let's use Crammer's rule. So Crammer's rule, using Crammer's rule. So we bring out the matrix. We have 5 and 4, minus 2 and minus 3. Alright, so here, so we go to 1 and 6. Okay, so what we want to do in Crammer's rule is first find the determinant here. So the determinant of this matrix will be this by this, that is 5 times minus 3, the expressive, the explicit, minus 4 by minus 2. This by this, minus 15, minus 8. Minus times minus plus, so we have minus 15 plus 8. This gives us what? Minus 7. Alright. So then delta x will give us, now to get delta x, we'll come and cover the x coefficient. Remember, if you're finding delta x, you cover x coefficient, replace it by the result. So when you cover up this, we have 1, 6. Are you with me? And minus 2 and minus 3. You did number 3, right? And you got an answer. Okay. Maybe not the right one, but an answer, right? Okay. Okay, so here we have, so delta x, now we have what? This by this, remember the main diagonal first. 1 times minus 3 minus 6 times minus 2. Alright, so this goes minus 3 minus 12. This time is plus. That becomes minus 3 plus 12. That is what? 9. I mean, when you interchange the thing, or you say minus 3 means I am owing 3, and plus 12 means I am having 12. And that gives us, that means I'll be having 9. Okay, so that's delta x. So delta x is this. So we now look for delta y. Delta y. So delta y will be equal to, we'll come and cover up the y coefficients and replace with this. Is that clear? So we'll come here, 5, 4, 1, 6. Okay. So the delta x, y therefore will be this by this, 5 by 6 minus 4 by 1. So this by this, 30 minus this by this, 4. Because this minus this, 26. Good. So to now find x, x will therefore be delta x over delta sharp. So delta x is what? We got to be 9, and delta was what? Minus 7. So x equals to what? 9 over minus 7, or minus 9 over 7, or you say 1 over 2 over 7, minus 1 over 2 over 7. Is that okay? In decimal? Oh, it's okay, but I prefer this. Perfect. And in matrices, usually we use fractions rather than decimals. You understand? All right. Then y equal to delta y over delta. Is that easy following me? Is that full or calculator? Oh, okay. So that becomes, what's delta y? 26 over minus 7. So that becomes y equal to this 7 in this 3. 3 remainder 5 over 7. So put minus, right? All right. Was this what you got? Okay, let's use the inverse method. So the inverse method will look tedious or more tedious, right? Did you use inverse method? You use this one, just stop there. I cannot come and kill myself. There's no problem. Okay, it's only number 3 you didn't use it. But use it for the rest. Sharp. And you got the answers to the rest. Good. You see, it's simple. So I wonder why. You see, I wonder. Okay, so we said that 5x minus 2y is equal to 1 and 4x minus 3y is equal to 6. So now using inverse method. So the inverse matrix method, we bring out the matrix also and minus 3, but this time in the product format. All right. So what you want to do is find the inverse of this matrix first. We know the method now, right? All right. So let's find the determinant of this first. So the determinant of this will give us 5 times minus 3. I think we got that here already, right? Then minus 4 times minus 2. So that gives us at the end of the day minus 7. Good. Okay. So we now say that the inverse of, let's call it A matrix. The inverse of that A matrix is 1 over determinant of A times the minor of this. So this guy goes there. That becomes minus 3 and 5. Then minus 4 and so what some people did in exam was you interchange there and also interchange there. That was what you did. You are not interchanging both. It's only mean diagonal that you interchange. So you interchange both, you mean diagonal without changing the sign or nothing or anything. Thank you. Where did you stop? Let's just continue. All right. So A inverse now becomes this by this. That will be minus this times this. That becomes 3 over 7 as minus will cancel out, right? Then this times this becomes minus 2 over 7. This times this becomes 4 over 7 minus will cancel out again. 5 times this becomes 5 over minus 7 altogether. All right, so this is the inverse of this matrix now. How do we now get x and y? We now use that guy to multiply the product, right? So the result. X and y will now become this guy, 3 over 7 minus 2 over 7, 4 over 7, and 5 minus 5 over 7. We'll now multiply 1 and 6, right?